Let's see the next topic in physics, that is power. So let's see the first question. Which of the following physical quantity measure the rate of work done? Okay. Which of the physical quantity measure the rate of work done? Okay, so let's see one by one. First one is impulse. Impulse, as you know, it is force multiplied by time. Okay. Momentum is what? Momentum is m mass into velocity. Force is what? Mass into acceleration. Power is what? Work done by the time taken. So if you see all of these options, only the power has something related to work, and since it is in denominator, time is in denominator, so it represents the rate. So rate of work done is nothing but power. Okay, so those who have given option D, they are right. Power is basically the quantity which measure the rate of work done. Okay, and we have seen in theory classes what is exactly is the power. So power is basically rate of doing work, how fast are you doing the work. Okay, so power means how fast work is done, and the formula you should remember, power is work done upon time taken. Since work is scalar quantity, power will also be the scalar quantity. Okay, so power is also a scalar quantity, and in this the unit of power is very important. Okay, the common unit is joule per second, the unit of work is joule, time is second, so joule per second. But the other and a very important one unit is watt. Okay, you have to remember what is the unit of power, and in term of CGS it is erg per second, and the others unit are there: horsepower, megawatt, kilowatt. And horsepower is the traditional old unit which is commonly asked in the exam, and more specifically the conversion are asked in the exam. Okay, and the popular one is 1 horsepower equal to 746 watt. Okay, so I have read somewhere that how much energy one horse is able to generate in the earlier days when horse were used. So in that case, James Watt uses this unit for measuring the power of the engine. Okay, so horsepower equal to 746 watt, and 1 megawatt is 1 into 10 power 6 watt. Mega means 10 power 6, W stand for watt. Kilowatt is 10 power 3, and 1 watt is equal to 1 joule per second, right? The next question, a very simple one: 1 horsepower equals what? Okay, so if you see, if you know the number 746, well and good, but you should also know the unit. Okay, so you should know that it is a unit of power. Okay, horsepower itself has a word power. So generally student will either go for joule or kilowatt or joule per second by looking at the unit, but it is watt. The unit of power is watt, and 1 horsepower is equal to 746 watt. Okay, this is very important question. 1 horsepower equal to 746 watt. Okay, and in this chapter the other important one are the numericals. Okay, the numerical says if a boy covered distance of 20 meter with 600 Newton force in 4 minutes, then amount of power consumed by the boy. Again, the very basic one formula, work done upon time taken, is power, and you need to calculate the work. Okay, so work is what? F into S cos theta, but theta I am assuming that theta is 0, so I am ignoring that part, divided by time taken. What is the force? Force is 600, distance is 20 meter, time is 4 minutes. You need to convert into second, so into 60. Okay, and if you solve this, you will get 50 joule. Okay, let's calculate it. 4 5s are 20. Okay, it is 10, so 5 into 10, 50. Okay, so 50 joule per second. Okay, 50 joule per second, or in other word 50 watt is the answer. Okay, so option A is the right answer. Let's see the next question. Again a numerical. Mohan, having a mass of 40 kgs, he climbs 50 steps in staircase in 10 seconds. If the height of each step is 15 centimeter, then what is his power? Again the same formula. Power is work done upon time taken, but in this case the work done will be change in potential energy by time. What is the potential energy? mgh. Mgh by time. What is mass? 40. G is 10. H is what? Here he climbs 50 steps, each step having 15 centimeter. So 50 into 15 you need to convert into meter, so divided by 100. Okay, so I am making it 0.15 divided by time taken is 10 seconds. So 10 got 10 cancelled. Again I have having 100 below me, okay, in the denominator part. So again if I cancel all 0, I am left with 5 4s are 20 into 15, that is 300. Okay, so 300 watt is the right answer. Let's see the next question, a theoretical one. Let's read it. A more powerful engine can do more work in less time, like aeroplane travel more distance as compared to car in less time. So aeroplane is more powerful than car. It is an example of which of the following? Okay, it is basically telling how powerful a vehicle is. Okay, since I am traveling in airplane, I can reach the distance far in less time. Okay, so I am doing more work in less time, so I am basically more powerful. Okay, so it is nothing but the example of the power. Okay, so which one is powerful? Aeroplane is powerful because it is doing the more work in less time. Okay, let's see the next one, but this time it is rounded to another statement. If a girl of weight 40 Newton, okay, climbs on the rope of 20 seconds with the power of 160 watt, at which height she will reach? Okay, so again power is equal to work done upon time taken. Okay, power is what? 160 watt, and she climbed for 20 seconds. What will be the work done? Work done, we know that it is mgh. So mg, this is basically he is giving in the Newton. Newton is force, force is what? Mg. Okay, so it is basically 40 into height, so it is 280. Okay, so it is, she is going to reach 80 meters. Okay, so 80 is the answer. So don't confuse that it is force, and we know that the force is equal to mg. So basically this is the weight. Weight is means mg. Okay, so it is basically mg, and h we need to calculate. Okay, let's see the last question for today's session. So the question says, what will be the average power required to lift an object of 80 kg to the height of 40 meter in 50 seconds? Okay, again you need to calculate the power. As we know, power is work done upon time taken. Work done we need to calculate. Time, it is given 50 seconds. Work done is again change in potential energy, then mgh. What is m? M is 80 kg. G, he is asking to take 10 meter per second square, and h is what? 40 meter divided by 50. Okay, so if you calculate 4 to the 8, 8 is the 64, 640. Okay, 640 joule per second is the right answer.